Hey, what's up? Mr. Bahork here. And today I'm going to talk about standard form. So what in the world am I talking about here? Well, you already know one way to graph lines. And what you're doing is, this is the equation that you probably have memorized / learned by now, the y equals mx plus b equation. And all that is just, it's an equation for a line. And when we graph this, okay, either by plugging in values for x and getting some y values, some ordered pairs, okay, we could do it that way, or use the slope and y-intercept. When we graph this, all this equation represents just some line. Well, there's other ways to write this equation. You don't have to write it in that format, y equals mx plus b. Instead, what we can do is we can write it in this format, okay? Ax plus by equals c. Now that seems kind of crazy because they've got some a, b's, and c's and stuff like that in here. So let me just explain real quick what those are. All a, b, and c is those are just constants. So a, b, and c are just constants. And actually, they have to be particularly picky about this. Okay, they are integer. They're integer constants. So that means that a, b, and c, they can't be like decimals or fractions or anything like that. They're just integer constants. So actually, that's not too bad. Okay, x and y are still x and y, and they represent like the ordered pairs that you can plug in. And then from there, you can't get the slope from the standard form, but it is useful in certain situations, I promise. Okay, I don't think it's as useful as y equals mx plus b, okay, but it is, I promise, it is actually useful. So let's actually graph an equation that's in standard form. I'll show you how to graph it in standard form, and then I'll show you how to take standard form and turn it into something that looks like slope-intercept form and graph it from there. In my personal preference, I think graphing in slope-intercept form is a lot easier, but we'll work with standard form because it's fun to know. So, ax plus by equals c. Let's come up with a good example. Let's say we're doing 2x plus 4y equals 8. Okay. Notice how a, b, and c, that's a is 2, b is 4, and c is 8. Notice how a, b, and c are all integers. Okay, there's no decimals or fractions or anything like that. So here's what we're going to do. We are actually going to find out what the x and y intercepts are. And that actually would make sense, right? If I know where it crosses on the x-axis, and I know where it crosses on the y-axis, well, then I can just connect those 2 points, and voila, I've got a line. So that's actually really, really helpful. So let's go ahead and do that. So how do I find out what the y and x intercepts are? Well, let's start with the y-intercept. Because remember a while ago we mentioned that what is the x-coordinate of the y-intercept? The x-coordinate of the y-intercept, okay, is always 0. Okay, remember that? That was a while ago. Okay, well, that's y-intercept. And what about the x-intercept? Let's probably write like x-intercept or something like that so it's not confusing. Okay, what about the x-intercept? Well, what do you think the y value is for any point on the x-axis? Well, the y value is 0 because you don't go up and down at all. So that means that if I want to find the y-intercept, all I need to do is replace x with 0. That's right. So let's do that, and I'm going to go over here to do that. Okay, so I'm going to replace x with 0. So 2 times 0 plus 4y equals 8. Well, 2 times 0 is just 0. So I got 4y equals 8. Divide both sides by 4. My sloppy writing here. 8 divided by 4 is 2. So the y-intercept is 2. 0, I plugged in 0, and I got 2. The y-intercept is at 0, 2. So let's plot that point. 0, 2 right there. Okay, now to find the x-intercept, I'm replacing y with 0. And then I'll find out what x is. So let me do that down here. Okay, so we got 2x plus 4 times 0 equals 8. Well, 4 times 0 is just 0, so I've got 2x equals 8. Divide both sides by 2, and x is equal to 4. So the x-intercept is at 4, 0. Okay, that's the point where I'll find the x-intercept. That's the point where my line will cross the x-axis, and that is right here. Okay, notice? Right there. And look, I've got 2 points. I can draw a line because I have 2 points. Okay, and we did that, and we don't even know the slope still. I'm sure you can find it because I know you're super smart. Okay, but we never even found the slope. All we did was we found the x and the y intercept, and we can draw the line, which is, I think, pretty awesome. So that's how you would find the x and y intercept and graph using from standard form. So let's say, you just don't remember how to find the x and y intercept, or you just don't want to. Okay, maybe you're just like, you know what, x, y intercept, no, I don't feel like it. And instead, okay, you're just like, you know what, I love slope-intercept form. And me personally, I love slope-intercept form. I think it's fantastic. So we can change anything that is in standard form to slope-intercept form. So let's do that. So I'm going to come up with an example. Let's say I've given you negative 2x minus 4y. Notice how it's kind of similar to the last one. Equals, let's say 12. Okay, I'll go with 12. Okay, so notice it's standard form because all the a, the b, and the c, they're all integer coefficients, and then the integer constant at the end. Okay, so this is totally in standard form. And what I want to do is I want to make it in y equals mx plus b form. I want to change it to slope-intercept form. So notice something though. Y is by itself in slope-intercept form. So I'm going to need to solve for y. I'm going to need to solve for y. So I got to get y by itself right here. So let me rewrite this real quick. Negative 2x minus 4y equals 12. There goes the bell. Okay. Anyways, I'm in a quiet classroom, so no worries there. So the first thing I want to do to get y by itself is let's add 2x to both sides. So plus 2x. Those cancel out, and leaving me with negative 4y is equal to 12 plus 2x. Now notice how I write this. I'm going to write 2x plus 12. That is the same thing. If you don't believe me, write down 12 plus 2x and then reverse them. You'll see it's totally the same. And notice why I write it that way. I want to make mx plus b. I almost have y by itself, but I need to divide both sides by negative 4. So I'm going to divide both sides by negative 4, and the shortcut here is I can divide the whole side by negative 4, but really what I'm doing is I'm dividing everything by negative 4. So this gets divided by negative 4, and this gets divided by negative 4. So let's go ahead and let's write out what we end up with. So I end up with y equals 2x over negative 4 is negative 1/2 x. And 12 divided by negative 4 is negative 3. And notice, look, I have my equation in slope-intercept form. Okay, it's in slope-intercept form. So I totally can graph that. Okay, I like graphing in slope-intercept form. It's not that bad. So there's my graph, abracadabra. And let's graph it. So the first thing I want to notice is the y-intercept is negative 3. So I'm going to go down and put my point at negative 3. And I keep accidentally hitting the scroll button. That's why it keeps jumping like that. Go back up. Okay. So there's my point at negative 3 very sloppily. Maybe I should redo that. Okay. All right. Much better. Okay. And now I'm going to use the slope to find my next point. And I'm going to rise negative 1 and run 2. So that means go down 1. There's the bell again. That means go down 1 since it says rise negative 1, and then run over to the right 2. So it should be right there. Alright, you know what? Before I draw this line, because I could go ahead and just draw the line between those 2 points, put the arrows on it, and bada bing, I'm done. I just want to show you something real quick. I started in standard form. I started with this equation, negative 2x minus 4y equals 12, and I just converted it to slope-intercept form. There is no difference between these two. Both of these equations represent the same line on the graph. Okay, there's no difference. They look different, but they both represent the same line. So just to test this out, I noticed that I already have the y-intercept, okay? And if you want to go ahead and solve out for the y-intercept, replace x with 0. And when I do that, I got negative 4y equals 12. Divide both sides by negative 4. And hey, the y-intercept is negative 3. So I should write that in proper form. 0, negative 3. So I've already got the y-intercept, and I just did that by plugging in 0 for x. Well, let's find the x-intercept, and we can make an even straighter line. So for the x-intercept, let us replace y with 0. When I do that, and I should write that over here, negative 2x minus 4 times 0 equals 12. Well, 4 times 0 is 0, so I got negative 2x equals 12. Divide both sides by negative 2. 12 divided by negative 2 is negative 6. So the x-intercept is negative 6, and writing it, writing it in proper form, if I can actually do that. Okay. The x-intercept is negative 6, 0, and look at where that x-intercept falls. It's right in the path of that line. So it must mean that this, I should probably write in a different color, that it means that this standard form equation is the same thing as this slope-intercept form equation, which is awesome. So let me finally go ahead and draw that line. I know you are all incredibly eager in anticipation for me drawing this line here. And there's my horribly drawn line. I totally missed that last point. It is incredibly hard to draw a straight line on this tablet here, so I apologize. But my line should go through all 3 of those points. Oh, and that's a good thing. That's a good way to introduce standard form. Now I want to do one more thing with standard form, and I'm only going to do one example of this because I don't want this video to be like forever long. I know you do because you love math. Okay, but don't know where that came from. Okay. I know you want this video to be long because you love math and you want me to do as many examples as possible. Okay, but calm down. I want to make more videos, that are a little bit shorter, break them up a little bit, commercial breaks and such. All right, so. All right, let's say, I'm going to make this is going to be kind of tough. Okay, let's say I've given you y equals negative 1/3 x plus 7. And you know what? I'm going to say make that into standard form. Oh my goodness. Make that into standard form. Well, step 1, remember, in standard form, that ax plus by plus or equals c, a, b, and c, they can't be fractions or decimals. They have to be integers. So before I even start, let's clear this baby of some fractions. So I don't like this negative 1/3 x, or I don't like this negative 1/3 here, so I want to get rid of that. And remember, you are allowed to multiply both sides of an equation by a number. We totally can do that, and it'll get rid of the fractions. So let me rewrite y equals negative 1/3 x plus 7. So in order to get rid of negative 1/3, I'm going to multiply both sides by 3. So 3 times negative 1/3 x, well, that's just negative x. Hey, no fraction. I'm doing good. There's my 3y from the other side, 3 times both sides. And then remember, I also have to do everything times 3, so don't forget 3 times 7 as well. So 3 times 7 is 21. And now I have something with no fractions. Well, to get this thing in standard form, I hope you can see it, I just want something x plus something y equals some number. All I have to do is add x to both sides. Plus x plus x. And now I've got x and y on the same side, which is good, because remember I want ax plus by. Those cancel out, and I'm going to end up with 21 by itself on that side. So let me write this in a nice, pretty blue here. I've got x plus 3y, or 3y plus x is the same thing, equals 21. And there it is in standard form, which is pretty awesome. All right, I'm Mr. Bajork, and this video was about standard form.